answer a number of questions you have. So the databases are all as it relates to material properties, and there are so many different material properties that we deal with as we do design on automobiles, bridges, turbines, and all types of infrastructure. We see, for instance, with changes in temperature, strength changes, ductility is affected, dimensions, expansion and contraction. And so there are many, many different material properties in the database for a large group of materials that should be very useful to your organization. We have four databases that make up the CINDAS product line. The two that will probably be most interesting to you are the aerospace and high performance alloy database, as well as the aerospace and structural metals database. The aerospace and high performance alloy database has about 275 different materials that are included, and the aerospace structural metals database has about 230. Also included in our databases are the thermophysical properties of matter database, and these databases are set up in a similar fashion to the AHAD and the ASMD. The only difference is that the TPMD is thermophysical and thermoradioactive properties, and for thousands of different compounds.
And elements.
And elements, yes. Yeah. And the microelectronic packaging materials database is electrical, mechanical, thermal properties of electronic packaging materials. So your organization certainly would be using the top two, the AHAD and the ASMD, and probably also the TPMD. Most of the presentation is going to be focused on the AHAD and the ASMD. The current users for the databases are both corporate and research companies, as well as academic institutions. For the corporate and research, the most significant is aerospace and aeronautical companies and defense. You certainly would fall into this segment. We also have companies from the oil and gas industry, automotive and other forms of transportation, a large number of power generation companies, and nuclear. The academic users would be most of the engineering fields: chemistry, electrical engineering, aerospace, material science, physics, mechanical engineering, and nuclear engineering. So that's on the academic side. Some common examples of CINDAS applications will include mostly in the aerospace field, design engineers, materials engineers that are making selections for different applications, and even some manufacturing engineers. I already stated that there are other markets and uses for the databases in automotive, chemical processing, marine, oil and gas, and medical. But the most important would be the aerospace and defense markets. Some examples of the important data on engineering properties for structural materials would include corrosion, the different types of corrosion that would exist and affect different specific materials, all the strength properties, both at cryogenic properties, room temperature, and elevated temperature, the modulus of elasticity and modulus of rigidity, elongation, fracture toughness, just about all of the important material characteristic properties for the metals and alloys in the database are included in the chapter, and we'll show you that as we get into the what is specifically included. This is the first page that you will see as you will get onto the ASMD or the AHAD. And notice this sheet is for the ASMD, and I think I mentioned earlier this would 230 different alloys or metals are included. So you can access and get in and start your search in 4 different ways. You can browse by a material group, and this would include, for example, there are over 25 different material groups, but you would have aluminum alloys that are cast, aluminum alloys that are wrought. You'll have nickel chromium steels. You'll have high strength steels, titanium. So if you don't know the specific alloy that you are wanting to find, you can go to the material group. You may know that it's a high strength steel, and then from that, there will be a drop down that you can see all of the high strength steels that are in the database. Or if you have a very specific material that you want to search, you can start with a specific alloy, aluminum 6061, or Incalloy. Or if you wanted a specific nickel and cobalt alloy, a Haynes 242, for instance. So here you would have a very specific material that you would search. Or you can start and look up a property group. And there are 224 different property groups that you can search. For instance, there would be strength, there would be creep, you could have cryogenic temperature strength, thermophysical. So that's a property group. And then you also could have a very specific property name that you wanted to look at thermal conductivity. And once you select thermal conductivity, then you can select the material, and it'll take you right to where that data would be for that particular material and the thermal conductivity or resistivity or all the different material properties. We'll see that in more detail. So if we wanted to start the search, we might search by starting property group, and we want to select the mechanical properties, and we want to look at strength. Now, in that same grouping, you would have a choice. You could select bearing strength. You could select compression strength. You could select tear strength or torsional. But for this example, we started with selecting mechanical properties and strength. So you see the mechanical property strength here. There are also another 20 groups that would be under that. And then here you have 25 strength properties, and from that you would choose yield strength. Yield strength would be a drop down. So once you hit that, you now see all the independent variables. And here we have temperature. So we have this blow up screen here. So these you could have selected and you're wanting to look at it at the independent variables. So you want to look at strength versus temperature. And here it's temperature in degrees Fahrenheit. You could have selected any of these other independent variables, and if there is data for it, that would appear. Once again, we have this in this database for 225 different materials have this property. So 225 different materials have the strength versus temperature.
And you also see that you have the temperature range that is included. So it's going from essentially absolute 0 to 3,800 Fahrenheit.
Yes. Yes. Right here. Yeah. So minus 453 Fahrenheit to 3850 would be the range. So now we have selected excuse me, we've selected tensile strength, yield tensile strength, and we've selected temperature and degrees Fahrenheit. Now we'll see in the next slide or one or two slides how we can change this. And we have to choose, we have to choose now material that we want to select to plot. And here we've selected material 106, which is nickel alloy Haynes 282. And you can see here's what would be the nominal chemistry. It would be nickel base, 20% chromium, 10% cobalt, 8.5% molybdenum, 2% titanium. So if you don't know when you're selecting Haynes 282, what's the composition? The nominal composition is listed here. So here we've chose material 106, which is the
red one.
Nickel 282. We've also selected material 108 and material 109. But this is just showing when we pull down the curves for the Haynes 282, material 106. And then you also have, once you make a selection on the material, you have to also select a, well, we'll get to that next year. So these are the curves for these 4 alloys, or 3 alloys.
you can select as many as 20 or 30, but the screen gets a little bit crowded. When we were putting this PowerPoint together, we just wanted to show you how you can differentiate between those. And selecting the curves, each curve has a set of conditions that they would, you need to go back a slide, Rob. There. Each curve has a set of conditions associated with that, and so you would be able to scroll down and see a brief description of those. And obviously with those three materials, there are sometimes 45 different sets of conditions or curves for each material, so it gets a little bit crowded, so we could only do a screenshot for the one thing. So
yeah, here, if you look here, for instance, for this material, for Haynes 282, we have a plot for a solution annealed, age-hardened, and its sheet. And then they have solution annealed, age-hardened plate. And then we have 1/8" sheet. We have something as welded and then age-hardened. So different conditions for the nickel Haynes 282. Now, notice also here that we can change the units. So if you want to click on change units, you would then have the option of going to different
pressure units,
different values. For instance, you could select KSI, which it is already. You could convert it to PSI. You could convert it to MPa. So you could create it to ATM. So you can select whatever value you want to change it. And from temperature, you can go, instead of Fahrenheit, you can switch it to centigrade. You can switch it to Kelvin. You can switch it to Rankine. So, there you can modify the whatever units are appropriate for what you're looking for. Now, this would be the same screenshot we saw on the last slide, but now you can hit the down select here and you can print this, or you can download different images or document, JPEG, or you can download a PDF. So this is just a way to go ahead and capture what you have created and either print it or download it. And you've got different options. Now, if you want to go ahead and take a section of the plots and expand the graph, you can click on that and drag that over and enlarge a portion of the figure, the plot, so that you have more detail, so that you can get more definition of a specific range at a specific tensile strength and temperature. Now, for each plot, so you have a material and then you have a set of conditions, you can now show what the actual data points are and the test conditions and the references where that data came from. So you can continue to drill down and find this data. So in this case, Here are the conditions for Haynes 282 that has a 2% offset yield strength for solution annealed age-hardened sheet. So now you come down, and so here are the conditions. So you can see this is the material, and the condition is solution annealed. It gives the actual solution anneal temperature, 2100 Fahrenheit. Then it's age hardened, 1850, 2 hours, air cooled, plus 1450 Fahrenheit for another 8 hours and air cooled. Then it gives the test condition. So, and then it gives the very specific data on both tensile strength, tensile yield, and temperature. The specific individual data points that are plotted on the graph. And if there are multiple curves from the same reference, from the same literature reference, it lists both of those. So this would be curve 1 would have this set of data, curve 2, and
the other ones would be there too, but it just wasn't on the same screen. Now you had to scroll down.
Yes. So at the very end, after you've seen the specific on conditions, the individual data points, here this is the reference. It's from this author, and it's from a Haynes International publication in 2009. So every piece of data is referenced back to a very specific reference. And then if you want to access this reference, you'd have to do a literature search to find that. And you could find the context in the reference, how the data would have been gathered, and some more information. So all the data in all the databases are taken back in this fashion to specific condition, specific data points, and a reference. So now if we're wanting to look at the PDF, we're wanting to look at the text of a given material, we can access it by on this screen by going to PDF here, or if you want to select the PDF for all materials, you can pull it up for a given material here. So here we selected material, and here's a list of, it's not all of them, but it's the start. So here you see all of these aluminum alloys, then we go to beryllium, then carbon steel T1, then cobalt alloys, all alphabetical. But you can see, so here would be the, it has the alloy name, in this case, aluminum alloy 2024. Here is the typical chemical composition. Aluminum base, 4.5 copper, 1.5 mag, 0.6 manganese, and also the UNS number. Often our customers are familiar with a material by the UNS number. That's not quite so common in aerospace, but in oil and gas and chemical processing, the UNS number is a very common way that some people will even identify a material. It said, we want you to use UNS A92024. So you have the alloy name, you have the nominal composition, you have the UNS number. So this, we had said, this is a what the start of a chapter would look like, the text for aluminum alloy 7055. This is the author. It was written in 2005. And all of our chapters in the ASMD and the AHAD are set up in the same fashion. They all start, you'll all find them, chemical, the commercial designations in 1.1. Hardness is all in 1.6. So if you look for any of the 275 materials in the different 275 different chapters, all of them are set up the same way. So if you're wanting to find something out about the hardness of 15 different materials, you would just come to the text. But there are different parts of every chapter, and the only point here is that you always find the same material characteristics always in the same place for all the chapters. So once you become familiar with how a chapter is put together, it's the same for all of them. And we'll always have room temperature properties. Then we'll have elevated temperature properties. We are elastic properties. Then at the very end of the chapter will be something on fabrication. But in all instances, every figure and every table has got a reference, and you can click on the reference and it will take you to the reference section, and it will then you'll be able, you want to see reference 1. So this was an Alcoa publication by these authors. So you can find the references in that fashion. Now, some of the data cannot be inserted into graphs, and so you would not be able to search it like we did earlier, but you will find it in the PDFs where you will find here is a bar graph, and here is a unique graph here that doesn't lend itself well to be digitized, but you would be able to access it in the PDF files in the chapter. Also included in most chapters, and especially the chapters that are the newer chapters, we've included photomicrographs. So in this case, this is for Haynes 263. Here's the anneal condition, and this is the heat-treated and age condition. So you can see different precipitation in the grain boundaries. So there are photomicrographs that are included in the PDF. So that's the PowerPoint. If you, as you study this more and you want to get back to us with any questions at a later date, you can see Patty's email address, my email address, and you can send any questions. Maybe now we'll go to the actual live database so that you can we can navigate around that and you can see something a little bit more detail.